Hello and welcome to this episode for Electromaker Educator. I'm your host, Robin Mitchell. In today's episode, we'll be looking at the entire Arduino Nano range to see their latest offerings, compare their specs, and figure out what they are good for. Let me give you a hint, being awesome. When it comes to choosing a microcontroller platform, one is faced with numerous challenges, as microcontrollers can have all kinds of varying capabilities, ranging from CPU type, speed, memory sizes, and peripherals. To make matters worse, not only do you have so many options to choose from, but then you have to plan ahead and try to think what your project will need. Will your project be using AI? Does it need Wi-Fi capabilities? Will your application require recursive functions and use lots of memory? All of these considerations need to be made. And well, it's never straightforward. This is a great example of why those with hindsight absolutely suck and need to keep their opinions to themselves. Of all the microcontroller platforms that are available to engineers, one has stood the test of time, the Z80 CPU, with its 4 MHz core and, wrong chip. That one hasn't been in active use since the 80s. Forget I said that. Nope, the one platform that has truly proven itself is the Arduino platform. Its first board, the Arduino Uno, demonstrated to the world how microcontrollers don't need to be complicated, require expensive programmers, or use complex software libraries that take a year just to get your head around. I know those 350 pages of register definitions are good reading when you can't sleep, but let's be honest, learning how to configure 5 different registers to make an LED blink is a bit excessive. When it became clear that users of the Uno wanted more oomph in their projects, Arduino decided to do the clever thing and release the Arduino Mega, with its ridiculous number of GPIO, improved CPU, and extensive memory size. Of course, there were also users who wanted to make small Arduino designs. Again, Arduino utilized their common sense and created the Arduino Nano, which was probably the first microcontroller board that could be fitted directly into a breadboard, be programmed over USB, and provide users with the same capabilities found in the Uno. Ever since the release of the first Nano board, advances in technology and the growing hunger from makers and engineers have seen Arduino release a number of Nano variations. Well, today we are in luck because they have sent me their entire Nano range, and you get to watch me talk about them. Of course, you don't get to have them, only I do. By the way, Arduino wanted me to compare all 7 boards to each other, but I'm pretty sure that's an n-1 factorial problem, something like 750 different combinations, so yeah, I'm not doing that. The Arduino Nano, the classic board that marked a new era for Arduino. This board is based on the Atmega 328 microcontroller, which has a 16 MHz core, 32 KB of flash, 2 KB of static RAM, and 1 KB of EEPROM. With 14 digital pins and 8 analog pins, there is plenty of GPIO to go around, and the fact that the Nano runs at 5 volts means that it's compatible with most circuits. The input power supply to the Nano can be between 7 to 12 volts, and this is handy for circuits that are powered by large batteries, solar panels, and turbines. Connectivity to this board is provided by a mini USB-B connector, and while these were all the rage back in the day of the first Nanos, they have slowly been replaced with the likes of micro USB and USB-C. But it is indeed a small, robust connector, and such cables are still manufactured, so you won't have any issues when using the classic Nano in a modern environment. The Arduino Nano ESP32, as the name suggests, is a Nano based around the ESP32 SoC from Espressif. Well, to be specific, this board uses the U-Blox Nora W106, which itself incorporates the ESP32 IC, along with all the needed supporting hardware to make it work. The Nano ESP32 has both Wi-Fi and Bluetooth capabilities thanks to the ESP32, and with a core frequency of up to 240 MHz, a flash size of 384 KB, and 512 KB of static RAM, the Nano ESP32 provides you with an insane amount of computational and connectivity power. For user applications that need more memory than the 384 KB of flash, an additional 16 MB of flash is incorporated into the board, which can be used for storing large files such as images, sounds, and firmware. Unlike the classic Nano, the Nano ESP32 is a 3.3 volt board, meaning that it cannot be used with older 5 volt circuits. But the input voltage from 3 to 21 volts is an excellent upgrade over the classic Nano, allowing it to be run on all kinds of different power sources. 2 onboard LEDs are also provided for use as quick peripherals, and one of these LEDs is an RGB variation which allows for any color to be generated. Finally, this board uses a USB-C connector, which makes it highly suitable for modern designs. Plus, it eliminates the issues with USB superposition, where you have to keep making multiple attempts to get your connector to work. This next board, the Arduino Nano 33 IoT, not sure why it's just called the Nano 33, is based on the SAMD21 microcontroller, which has an ARM core clocked at 48 MHz, 256 KB of flash, and 32 KB of static RAM. Wireless connectivity, both Wi-Fi and Bluetooth, is provided via the u-blox Nano W102 module, and anyone who has u-blox products before will know that they are absolutely top quality. One feature about this board that makes it stand out is its inclusion of an ATEX C608A, bit of a mouthful, secure element, which provides cryptographic and authentication functions. This makes the Nano 33 IoT extremely secure, but more on this later. Also integrated into this board is the LSM6DS3 IMU, which provides 6 degrees of freedom via a 3-axis gyroscope and a 3-axis accelerometer. This is great for those who want to interact with physical movement, such as game controllers or VR and AR systems. The SAMD21 Micro also supports native USB, which allows for creating USB devices, and the power of the u-blox module is so vast that it can be used to run a small Linux system. This allows for the SAMD21 to provide low-level GPIO access, while the u-blox module provides high-level system functions. Finally, the Nano 33 IoT operates at 3.3 volts, can support up to 21 volts on its input, and uses a micro USB cable, just like many of the other Nano boards. Up next is the Arduino Nano 33 BLE and the BLE Sense. Yes, I'm being a bit cheeky and covering these two boards here, but that's because they're very similar, and not because I'm very lazy. Anyway, at the heart of these boards is the Nordic nRF52840 microcontroller, an MCU that has plenty of experience in the field of professional commercial devices. This MCU has a core speed of 64 MHz, 1 MB of flash memory, and 256 KB of static RAM. But what makes this microcontroller of particular importance is that it supports Bluetooth Low Energy and consumes a very tiny amount of power. As such, the Nano 33 BLE and BLE Sense are ideal for low energy applications running on batteries. But again, more on this later. Let's not go spoiling the applications chapter. Native USB is provided via the nRF52840, which makes it ideal for USB projects, and the use of a micro USB connector makes it compatible with older Nano projects. However, as it is a 3.3 volt device, it cannot work with older 5 volt circuits, but the input power supply of up to 21 volts makes it easy to power. Now, where the differences are between the BLE and the BLE Sense is that the Sense has a bunch of extra sensors. To be specific, the Nano 33 BLE Sense integrates an MP34 DT05 microphone, ADS 9960 gesture, light and proximity sensor, LPS33HB barometric pressure sensor, and finally a HTS221 temperature sensor and humidity sensor, which is a lot of sensors. So there is clearly a lot going on with the BLE Sense. Now it's time to look at what is probably my favourite of the Nano boards, the RP2040. For those who have seen my other video about the RP2040, you will know that I absolutely rave about this microcontroller because of its high specs, range of peripherals, and simplicity of use, simplicity above all. The RP2040 has a 133 MHz core, 264 KB of static RAM, and utilizes an external 16 MB flash chip for storing program code. As the RP2040 appears as a flash drive when programming, updating its firmware is trivial, and this also allows for storing files that can be used by applications, especially in MicroPython. But the Nano RP2040 goes one step further thanks to the incorporation of the u-blox Nano W102, which provides Wi-Fi and Bluetooth. This module integrates 448 KB of ROM, 520 KB of static RAM, and 16 MB of flash, so again there is plenty of resources. With regards to security, the Nano RP2040 integrates an ATEX C608A MA HDA secure element, providing cryptographic functions and authentication. There are also two sensors included into this board, a 6-axis IMU and a digital microphone. Finally, the RP2040 Nano operates at 3.3 volts, but again, like the other boards, the input power can range from 3 volts to 21 volts, and connectivity is provided by a micro USB connector. The Arduino Nano Every is an interesting variation of the Nano, as it provides an upgraded version of the Nano while still being significantly cheaper. At the heart of this board is the Atmega 4809 MCU, which integrates a 20 MHz core, 48 KB of flash, 6 KB of static RAM, and 256 bytes of EEPROM. These specs are far better than what the Nano Classic offers, which makes the Nano Every a no-brainer for new projects. Just like the Nano, the Every also operates at 5 volts, which makes it backward compatible with previous Nano projects. But an extra feature of this board, which makes it highly practical, is that it has no components on the underside. This means that it can be used with custom PCBs as a module that is directly soldered to the board without the need for headers or spacers, being completely flush. Finally, this board uses a micro USB connector, so you won't have any issues finding replacement cables or connecting to other embedded systems. Okay, so now that we have taken a quick look at the specs of each of these Nano boards, it's time to figure out where you'd use each one. Starting with the Arduino Nano, while it was certainly ahead of its time when it came out, now that technology has significantly progressed, it's become a bit of a legacy product. As such, you should really only consider using this board if you have an older project that requires a Nano replacement and absolutely must use the Nano. If you need an Arduino Nano, but it isn't essential that you use the original, then the Nano Every is a far better choice as it has better specs, is much cheaper, and there are no components on the underside. But if you insist on using a Nano, then it's a great board for small projects that have hardware focuses, such as controllers, sensor interfaces, rapid response systems, and autonomous robots. The Nano ESP32 is an excellent workhorse for any Wi-Fi and Bluetooth project. As the ESP32 is well supported across all engineering communities, you won't find any shortage of example projects, libraries, and boffins online willing to help you with any issues that you may encounter. While security on the ESP32 may be lacking to some degree, meaning you should think twice before using it in applications where privacy may be of concern, that doesn't mean you can't use it to create smart home devices, wireless controllers, and plenty of other cool IoT gadgets. Additionally, the ESP32's obscenely powerful processor and memory make it an absolute beast when doing advanced projects such as VGA controllers, tiny operating systems, and interfaces. Of course, this means that it isn't exactly the best when needing to save power. The Arduino Nano 33 IoT is an extremely secure device thanks to its secure element chip, which makes it hard for hackers to inject malicious startup code, break encrypted memory, or hack the device remotely. As such, the Nano 33 IoT is an excellent candidate for those looking to create IoT projects that need to ensure privacy. Such examples could include wearable medical devices, cameras and microphone systems, and even in cryptocurrency applications, so you could quite easily use this as an offline storage for some crypto. The separation of the main processor from the wireless module is also beneficial as it frees the CPU from network-related tasks which are often very heavy. Thus, the Nano 33 IoT is also ideal for use in applications where real-time low-level hardware signals are being used, such as motor controls, sensor monitoring, and signal timing. The Nano 33 BLE is an excellent option for those looking to create low-energy Bluetooth projects. As the Nano 33 BLE is supported by the Nordic and Arduino development environments, you won't be short of programming options, examples, and libraries. The low-energy nature of the NRF52840 also gives users the option to run from small battery sources for extended periods of time, meaning that projects can seriously reduce their overall weight. As such, the Nano 33 BLE is ideal for use in wireless devices such as headphones, microphones, and wearables and medical devices, but could also be leveraged in small autonomous drones, including those that fly and even possibly in a small rocket guidance computer. For those who want to create a Nano 33BLE project with a wide range of sensors, then the Nano 33BLE Sense is a better choice due to the numerous integrated sensors, including the IMU, microphone, temperature and humidity sensors. This makes the Nano 33BLE excellent for numerous Bluetooth projects such as wearables, medical systems and even environmental sensors. The Nano RP2040 is excellent for those who want to use the RP2040 with both Wi-Fi and Bluetooth. The low-cost nature of the RP2040 combined with its powerful range of peripherals makes it ideal for use in hardware projects that need wireless connectivity. Additionally, the PIO peripheral in the RP2040 also makes it excellent for low-level signal conditioning and custom bus protocols, and the ability to utilize MicroPython provides makers with a powerful programming environment. When taking all of this into consideration, the Nano RP2040 is great for projects that need to be developed rapidly, utilize the Arduino programming environment, and need wireless connectivity. Such projects could include wireless devices, small drones, sensor stations, and hardware controllers. However, just remember that as the RP2040 doesn't have code protection, nor can it encrypt the external flash, it's highly susceptible to hacking, so don't use it where security or privacy is important. Now we get to the part of the video which matters the most, my opinion. Of course, everyone wants to know what I think, and I'm always right. I think. Anyway, in the safe words of a famous meme, I will tell you what board to get, but I don't know though. So, now that I'm absolved of all responsibility, I would like to say that choosing a Nano board is very tricky because, as we said earlier, it can be hard to choose a board as you never quite know what specs you will need. But after careful consideration, my two choices would be the Nano ESP32 and the Nano Every. The Nano ESP32 wins my heart because of the powerful processing capabilities that it offers. You can use the ESP32 to do so many brilliant projects, it can be used as a standalone microcontroller, and the ability for it to interact with low-level pins at high speed makes it a good all-around candidate. Furthermore, the ESP32 is just so well supported. It can be used for IoT projects, Bluetooth projects, and even as an industrial controller if you wanted. There really are no limits to the ESP32, so for me, the Nano ESP32 is number one. Oh, and if you weren't sold on the Nano ESP32, it uses USB-C, which is my favourite connector in the whole wide world. But if I need a simpler device, whether it's to blink an LED, drive a motor, or display some text on an LCD, then the Nano Every is a clear winner. Its low price break makes it a no-brainer, and its improved hardware over the Nano Classic means that you get more bang for your buck. What also makes the Nano Every an excellent choice is that because of its simplicity, it is easy to understand at a low level, including its registers. This means that coding low-level programs in assembler and directly accessing registers isn't a painful experience. So, if you want a cheap development board that works with the Arduino environment, the Every is an excellent candidate, and certainly one that is being stocked on my shelf. Just before we wrap up this video, I thought it would be a great opportunity to mention that all the Nano boards shown in this video are compatible and work very nicely with the Arduino Cloud, which is an extremely lightweight and easy IoT platform. While I won't go too much into detail, as that is another video in its own right, I can assure you that the Arduino Cloud platform is an absolute beast because honestly, it just took me less than 2 minutes to open a Nano board, connect it to the Arduino IDE, program a cloud example, and get data stored and shown on a dashboard. Try doing that with another platform. Seriously, Arduino, I don't know who is your lead programmer and designer, but honestly, they need a raise. Now that you have seen the entire range of Nano boards, it's time for you to go and build your own monstrous creations. Will you go wireless? Will you go simple? Do you need security in your project? Or do you need something that's fast? Well, with the information given in this video, I'm 65% confident that you'll be able to go out and choose the right Nano for your next project. If you want to help support the work that we do here at Electromaker, then head over to the Electromaker store where you can find all the Arduino Nano boards shown in this video, along with all the bits and bobs you could possibly need for your next project. Thank you for watching. This is Robin Mitchell, signing off.